Started the recording. Anya, all to you.
Okay, cool. Hello, everybody. Today we will be talking about the book called Agentic Design Patterns. And my task for today is to present the preface of the book, just talking about what does it mean, AI agent, and how it's different versus agentic AI. And then I will be talking about chapters 2, 3, and 4. Um, Yeah, and I will be stopping after each chapter just to allow some time for questions or for reflections. When I will be talking about like all those parts of the book, I will be asking mainly myself questions just because otherwise any new information I consume doesn't stick to me. I need to understand the questions first. And then I find the answers and I try to connect the answers to the things I know specifically. So what you will see in my presentation, some connections to the real world case studies, some connections to the frameworks I know. Yeah, I apologize in advance if it doesn't make sense to you, but maybe you will learn something else, not only from the book. So for the preface, as I said, the author talks about what does it mean to build an agentic AI and what is different between uh, agentic AI and AI agent and the difference between all of those and LLMs. And he introduces a very simple framework to think about it. So for the preface, we will explore key characteristics, the differences, the core components, and to me, what was the most interesting part of that part of the book, this metacognitive abilities, as the author says, which are real value differentiator. So when it comes to the AI, agentic AI, the author proposes that it's about understanding the environment, um, possessing skills to achieve the results, constrained by the goals and guardrails. I'm providing here a picture from the book where the author explains it's about like getting the mission, scanning the scenes, thinking it through, and then achieving results, which is a new concept for me. Um, but in my head, it connects to the framework I know and love, called OODA. It's observe, orient, decide, and act. Just because I'm coming from the enterprise space, I saw that framework used in many big corporations to make decisions when the time is precious. And fun fact you haven't asked for is that this framework was introduced in the 70s by an airline, by an army pilot. They needed to make decisions quickly when their plane was spiraling. So yeah, for me, I understood the definition of the agent. It's about being autonomous in achieving defined goals and understanding the environment and observe, orient, decide, and act. Loop made sense for me more than the thing I saw in the book. What made sense for me in the book is this framework, just because I personally struggle to understand what's the difference between an LLM, AI agent, and then agentic AI, reading all the blocks and seeing the last two terms being used interchangeably didn't help. Now I have a much clearer picture and I'm sharing it with you. So based on my understanding of the book, we started 4 years ago, 6 years ago with a simple LLM workflow. Then we provided the tools for the agent to retrieve more information. Here, an example of a RAG. And then the book focuses on the last two parts, on the higher two parts. AI agent is a single entity that has on top of the tools some metacognitive skills, and we will explore those skills in one slide. And a number of collaborating AI agents is agentic AI. That's how I understood it. It made things for me much clearer, and I'm able to read more blogs with that understanding. When it comes to the book, what also I struggled with, the book has 21 pattern. I'm able to memorize maybe only 4 or 6 separate objects or entities when I'm reading something. So I try to organize it in a structure against this framework. So what I will be talking today about, it's the routing and parallelization, and we will talk about reflection, which is a part of metacognitive skills. And Anton last time talked about prompt training, and you see that the book spent some time, not a lot of time actually, about talking about agentic AI, just because it has only 2 chapters allocated for that. The majority of the book is on level 2, and we will talk about reflection today. And I kind of organized those patterns into several groups. It was important for me to chunk out the metacognition patterns, which is reflection, planning, goal setting, and monitoring, and prioritization, just because it makes the agent much more strategic. Unfortunately for me, in the book, all those chapters are kind of organized in a known manner. So the question I have for the group and maybe for Anton, if we want to continue moving through the chapters as they are, or maybe we want to kind of chunk them up to create a better understanding. But I will pose that question at the end of the call. So this is all about agentic AI and the difference between AI agent and agentic AI. I'm happy to go through the routing chapter, but before that, any questions or observations you want to share? No. Let's move on. So for the routing part, the questions I asked myself is about how, like, you can understand conceptually what routing means, deciding, choosing, allocating a particular task to a particular agent or a tool. But the questions I asked myself are, what are the ways to decide where to put the request, and could it be dynamic or could it be only static? And then who decides how to route all the requests, supervisor pattern. So those are the questions we will explore. So if you read the book, and I think we understood it on Monday, the book is a bit unique just because it provides information in a very relaxed manner, at least to me, and it has code snippets, which I'm not able to consume personally from the page of the book. So I went outside of the book to explore some of the concepts I was interested in. So when it comes to the routing, it's about choosing between multiple potential actions based on what agent understands. And I'm talking about the agent here, like a single agent. So what I understood from the book about the routing is that there are several ways to conduct it. Moving on from the least complex and most static to the most complex and least static approach, you can route based on rules, using keywords, let's say, so rule-based. You can route based on the embeddings, trying to understand the intent from the ask and mapping it to one of the predefined buckets of tools or other agents. You can do it based on some kind of classifier. The book suggests using a ML-based classifier that you can train additionally. And the last bit and the most complex in the book is that you can use an LLM, which is a supervisor in relation to all the other LLMs that interact as a part of this agent who decides where to put this particular query. And an example from the book is that you have a query and you read it and you understand it's more about the product status, user support, or other. So this is the patterns outlined in the book. I also saw another pattern outside. It's this reverse kind of supervisor called auction-based routing, and it's about agents bidding uh, for for the task. We will look at it. So it kind of, to me, it reminds the reward function in reinforcement learning, and we will get back to that when we will talk about reflection. But yeah, those are the patterns. And what I also saw um, researching some of the articles and PDF file I will share, and you will be able to click on all of that. So some of the articles suggest very repeatable approach when it comes to routing, and the most interesting things from the best practices for me were trying to cut the tasks as non-ambiguous and kind of not overlapping. In consulting, they say mutually exclusive something something. Let me see. Sorry, I forgot. Also, the recommendation was to always implement a default fallback pattern, maybe to other or to something else, and measure the accuracy of that part separately, just because if not done accurately, of course, it will dramatically decrease the accuracy of the whole system. When I'm saying measure accuracy, I myself still explore what are the frameworks available to measure accuracy of the agentic systems repeatedly, just because it's my gap. So maybe we will talk about it later. And the last bit I wanted to say about routing on this slide is that, as I said, it could be static or dynamic. Static means the categories are the same and maybe the models and the agents are the same. Some people talk about dynamic routing, and it means that mainly you decide to route based maybe on models availability or the state of, I don't know, your tokens or rate limits you have. And the last bit, you can decide to route to different models based on their strong suits, on their superpowers, whatever they do the best, which was interesting to me. So, yeah. I was interested to understand how this specific pattern looks in real life, and one of the most interesting case studies I found, it was GitHub Copilot, and what they have, yes, they have specialized agents that kind of pick up a particular task and then put it through a pipeline of agents: plan, brainstorm, repair, and specification. And they have 4 types of tasks. Big ones: solving issues, refining pull requests, creating repositories, and ad hoc, which I assume ad hoc being the default fallback scenario. And what they say about their approach, they apparently use something embedding based solution. So you can see they try to understand the intent and kind of push it through, which was quite interesting for me to read. And I'm providing the link if you want to read more. What else I found about routing? I found that it's a known fact for other people that when you try to route and you provide an agent with the tools, the agent ignores the tools or uses inefficient tools. So there is a pattern, and you have the link here, or it's on GitHub, about how to write prompts for the agent to not to ignore the tools and use them better. So they call it provide tool selection for the repeating tasks. And what I also found to my not surprise, but it was cool, when it comes to routing, there are a lot of kind of sub patterns or repeatable ways to do things in security area. And what they do, they kind of create those isolated LLMs. One of them, let's say, consumes what user wants, but doesn't have access to the tools, and the other one only gets cleaned up version of what the user said and only has access to the tools, which is cool. So this is the routing part. As we discussed, there are multiple ways to do it, starting from the rules, ending with a supervisor LLM. It could be static and dynamic. Yeah. Any questions about the routing part? Anything you want to share from what you know, or you believe maybe I mispresented?
Do you think that eventually routing will be moved to the LLM layer? Like, as I remember, GPT-5 is doing something like that, right?
Yes. Uh, it's actually a very good question, just because I started in parallel to research, like on the back of Anton trying to connect Solid to the AI world. Started to research what are the frameworks and ways of thinking about AI agent development exist. And one of them is that the recommendation is to build scaffolding, not features, just because they expect that eventually everything will be sucked into a very smart LLM. So answering your question, eventually, but not now. But also, like I'm coming from like I don't know, very traditional, not traditional, but enterprise with real money, and I'm always thinking about when I build things like that, do I want to give up control on that part of the logic? Just because, yeah, everybody celebrates things being sucked into stuff, but then you're very dependent on this very smart, very innovative thing. Yeah, as a
Yeah, I
business.
agree. It's
Mhm.
still nice to have some control, but probably in reality in the future it will mean that, all the system will be complex, routing at the agent level, routing at the
Mm,
LLM layer, routing at the infrastructure layer. Oh, a lot of fun.
yes, yes, yes. I'm coming from AWS space historically, so when I see that, I'm thinking it was like gateway, security gateway, or like router, like network access router, thinking maybe all the people who now write agents will introduce components like that, kind of repeatable ones. Okay, let's move on. Any other questions? Okay, next part, parallelization. So we are kind of still in the land of the simplistic AI agent, right? We are not talking about anything that allows it to make itself better. So parallelization, another pattern, and you will again see me kind of going outside of the book just because I don't know how about you. I'm reading a book to perform better in the interviews. So I need to understand like specific questions and specific answers. So for parallelization, two questions. What are the benefits and trade-offs? when do we introduce parallelization, and what are the limitations, and yeah, what are the challenges? Again, to the best of my ability. So in the book, there is not enough for me information about pros and cons. If you open the book, you will see that the guy is explaining the user scenarios when parallelization is useful. So kind of doing data analysis, kind of doing several types of analysis using the same data or slightly different data, writing an email, creating a marketing email, kind of creating a picture in one model, creating text in another model. You can read those scenarios in the book. I wasn't sure that like this audience, including me, is interested in the business scenarios. So I went in a different direction, and I tried to combine to compound what I saw. And there are three things I want to talk about, like 3 slides. First slide, this one. So when it comes to parallelization, trying to do things at the same time, all the frameworks outlined in the book, and all the big frameworks, I don't know, Crew AI, they have built-in constructs to write parallel logic for the agents. And how people deal with that parallel logic is that one of schools of thinking is to divide the tasks or divide the tools into 2 buckets. One is the read-only bucket, and another one is the write bucket. So write means changing the environment or changing the information. And this pattern here, I provide the link to, actually 2 of them. They kind of talk about, yeah, let's divide tasks or tools into buckets. And if the tool belongs to the read-only bucket, let's run it in parallel. If it's not, then we will do it sequentially, which I believe very smart. And the second thing on this slide I wanted to highlight is that when it comes to parallelization, you want to be vigilant of how many concurrent requests you use, and of course, rate limits and token limits, just because you can go as hard as you want, but maybe you don't have enough tokens for that. So read only and write, and of course, you save time with parallelization, but at the expense of maybe costs and tokens. What I saw a very similar pattern from my software development history. The pattern is fan out, fan in. So you kind of fan out and then fan in, which is parallelization exactly in AI world. And an interesting thing I saw, again, related to security, it's just because I'm interested in how kind of agents work in enterprise where everybody is worried about doing the wrong thing and like an agent being hijacked. So another pattern finally called map reduce. So you kind of use several LLMs at the same point of time to ingest different parts of information and clean it up, and then reduce it back to have like this one big cleaned up, I don't know, blob of context or blob of information to work with. So that's what I saw somewhere else. What I also saw, how people use parallelization combined with the best of n. So it's another pattern. I saw it earlier when LLMs were being used without any agent attached to it. So you kind of ask several different models to produce an output, and then you judge it. And we will talk about judging in the last bit, but you produce outputs and you judge it. So it's a practical way to illustrate how parallelization works. So you can see in the pattern I'm providing, they use different models for different tasks, depending on which model is the best suited for the task. And then, of course, using a judge, combine it. So that's how parallelization plays into a bigger context. I think it should be the last slide. Yes, again, I work better when I understand how other people did it. I found this example from Uber. So they reworked their code development and testing approach. Now they have a couple of AI agents. And what happens, they, instead of kind of using parallelization, maybe they use parallelization inside each agent, I'm not sure, but what they do, they spin up a lot of AI agents in parallel so they can conduct tests in parallel. And how they conduct tests, they have this repeatable way of several agents working one after another and kind of going back, I assume, doing some reflection pattern. But what is interesting about their case, and I really like the video. I even watched it like without notebook LM, like watched it. They talk about how did they build this agent. Yeah, I think it's the last one. Yes, so for the parallelization, my summary is that kind of cool, you save on time, but you can be hit by the rate limits, and you can use it inside the agent itself, or kind of spinning up multiple agents. Yeah, and yeah, it's kind of this old pattern of fun out, fun in is the use in software development. Any other observations, guys, you want to share? Uh-huh. Okay, moving on to the last one. I saw chat. Mm. Ooh. So the reflection part, so the reflection part. The questions I would like to answer is, yeah, what is the difference between reflection and error handling? And what are the ways to implement reflection? That was the most interesting part for me to dive deep, or just because, yeah, I knew the least about it, to be transparent. So reflection is defined in the book is to ability to think about agent on actions and results to self-correct and improve dynamically. And based on my understanding, like the reflection conversation we have in agents now started actually a couple of years ago with the thing called React. So long time ago, in AI means 2-3 years, people understood that if you ask an LLM to perform a task as a part of their kind of, I don't know, reasoning process, the results will be better. So reasoning and acting means react. So you get better results. And then year after, another framework was introduced called reflection. I don't know how to pronounce it. Reflection, which is X. So it was talking about the agents already, not LLMs, but the agents. And the idea there was that you produce an output, and then this output is being evaluated against a set of goals. We are not talking about the goals yet, but we will. Somebody will. So evaluate it against a set of goals or a set of rules, and then it's being regenerated using the feedback provided. Yeah, so if the first React was about like thinking and doing, the second one was about exactly learning from mistakes. And if we kind of dive deep into how reflection could work, there are several ways to do it. This is from the LangChain website, just because it was the best source for me to understand what is available. So you see here the basic one, which means you have one model that does the job and another model, the judge or the critique or whatever name, who does the reflection and kind of uh, puts it again for the doing model to do better. So this is the basic reflection. Reflection actor, it's slightly different scenario, again based on LangChain. You have the first responder and then the reviewer who is doing the refinement in a cycle. And the last bit, which I'm not sure will be used or is being used somewhere in real agents, because it looks like something from the internals of LLMs, but effectively you use a bit of like similar to reinforcement learning reward mechanism to generate the answers and then reflect. So why they're using this scenario is that sometimes they want to avoid getting a mediocre answer or a mediocre result, especially for the tasks that require a lot of like reasoning and thinking out of the box. All of those, I assume, so on the website, they have the links to the code, so you can have a look at the code. What I really liked about reflection and how I memorized it, reflection is the first pattern in AI agent that makes the operational flow cyclic. So before that, we talked about prompt chaining, parallelization, and routing. All of that was more or less sequential, even parallelization. But this one creates the first kind of feedback loop, and we will see with all the other with many of the other patterns from the book, like this reflection loop will be intensified and made more elaborate with all the other things such as memory, guardrails, planning, all of that. So yeah, for me, reflection is the first pattern that makes an AI agent an AI agent and not an LLM with tools. Yes. So for the reflection, yeah, the first metacognition patterns. And what was interesting for me, yeah, it increases the quality of your answer, but of course, trade-offs. You have increased latency, you have higher computational costs, and you need to watch out for the tokens being used. And just because it's like the first metacognition pattern, every time when I'm trying, and you, I assume, hear it, every time when I'm trying to talk about reflection, I immediately want to go into other things that make reflection better, such as memory, goal setting and monitoring, because reflection is done against things. Yeah, and I found a couple of examples of how other people kind of try to elevate reflection. It's a bit of an old one, Constitutional AI by Anthropic, where they explored how LLMs, not agents, but LLMs could behave having human-focused goals and values. Yeah, it's a bit an old one from 2022, maybe like the most recent one with their model scheming to grow the vending machine business could be better here, just to show the impact of reflection not done right or goals not done right. And another thing I found interesting, it's a paper that talks about self-taught evaluators. So what they do, they make judge. So the judging agent who reflects on the things, also memory enabled. So you not only make the, I don't know, the action agent better, but you also the judge agent better, which I believe is cool. And solve for all kinds of drifts. I'm thinking if I have any. Yeah, that's it. So for the reflection, that's it. So we understand that you can have it multiple ways, a simple one with two models or a complex one with trees, and you need to watch out for tokens, of course. And yeah, you need to watch out maybe for this, like this judge being stale, but there is a way to do it differently. Any questions?
Again, I'm seeing a lot of overlap with the thinking slash reasoning built in into LLMs these days,
Mhm.
right?
Yeah, I don't know, Anton, if you want, just because I do it anyway after the book, after we finish the book, or maybe at the end of the book, I'm happy to extract from Obsidian what I have about like fashionable frameworks to develop AI solutions, and I can present it too. Okay. Any other questions? I think then we are done.
Awesome.
Wait.
Awesome.
Yeah.
Thank you for presenting.
So, Andrei, sorry, I named you Anton in my head, and
No
I'm
worries.
sorry for that. It won't
Um,
happen again.
yeah, I'll survive that. So yeah, thank you for presentation. And guys, please DM me if you want to present any other further chapters. And yeah, I guess this is really it. So I'll stop the recording